Hey guys, welcome to Great Learning. Have you ever wondered how Facebook automatically tags your friends in the picture that you upload? How does it know? Well, this and thousands of other applications are possible because of OpenCV. It is one of the most popular computer vision libraries out there. And if you have landed on this tutorial, I am sure that you know that OpenCV is trending across all domains and researchers and developers alike are interested to hire experts here, right? Now, keeping exactly this in mind, we here at Great Learning have come up with this OpenCV tutorial that will help you get started with the library. We will discuss a good amount of theory and multiple practical demonstrations using Python to help concrete your understanding. With that, I know you guys are super excited to get started. Well, what are you waiting for? My name is Anirudh Rao. Let's go.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.
Alright guys, so to take a look at the session agenda that we have planned for you guys today, for this OpenCV tutorial, we are going to have to start out by understanding what OpenCV is, right? Now, some of you might have used the library, some of you have used applications which are being done based on these libraries and a lot more, but to get a complete understanding of what it is, how it works, how you can all set it up, we need to know where it is used popularly, and we need to also understand how it works as well, right? So we're going to discuss all of that, and we're going to also make sure that you guys are installing OpenCV in your machines. Now, there's multiple ways of installing OpenCV. I'm going to be showing you all these ways, and of course after this, guys, we're going to be taking a look at some demos, practical demonstrations done in Python to make sure that you guys have an understanding of it. First of all, we'll verify if the installation went well. We're going to take a look at the latest versions that are available, after which we're going to be doing some really interesting OpenCV operations, right? These are super fun to work with, and they're very easy, and yet at the same time they have a powerful outcome as well, right? So we're going to take a look at all of that, and once you understand these basic operations, next you'll be very curious to know about the concept of how computer vision even works. How does your computer even know how to look at an image and figure out what it is? So we're going to look at that process to a good amount of detail. Now, once we have discussed the OpenCV process, and once you understand how computer vision itself works, and you've also taken a look at the basic syntax with respect to how OpenCV operations work, the next thing we're going to take a look at is dive right into the heart of a fantastic face detection example, where we'll be taking a couple of pictures of mine and making sure that we get our OpenCV library to detect my faces in multiple pictures of these, right? So it's going to be a super exciting session. I hope all of you all are excited as me, right? All right, guys, on that note, let us get started with the first item on the agenda. Introduction to OpenCV. Now guys, OpenCV is one of these libraries that are present in Python, which has seen a lot of usage. Now, as you heard at the start of this video, how do you think your computer, or how do you think Facebook even knows that as soon as I upload a picture of me and my friend, how does it know whom to tag? How does it know that it's a picture of a person? And probably recognizing that it's a person can be easy, but recognizing who it is among millions and millions of Facebook users, and of course through your friends, that is what takes skills, right? So OpenCV is not a standalone thing wherein you're teaching your computer how to look at images, but 99% of the applications that we use is where OpenCV is a part of it, right? Now, I can assure you all, even though you might have not uploaded a photo to Facebook and tagged your friends automatically there, I promise you that you have used OpenCV and you might have had a very good chance to take a look at it, right? Now, every time you open up your mobile phone and go to scan a QR code, how do you think your phone understands that it is seeing a QR code and it has to only scan that part, right? give it a thought. Every time you eat at your favorite restaurant, every time you step out, I hope all of you are wearing masks while you do. Now when you go on to do that, when you're going to eat or something like that, you realize that paying with UPI is a very simple click of a mouse button or your phone click, right? Now you might be not exactly zooming in on the QR code that is present on the UPI scanner, but at the end of the day, if you just point it towards that direction, your phone automatically picks up the UPI ID, the QR code, whatever it is, and eventually you can send or receive money, right? So how does this happen? Now, OpenCV actually stands for Open Computer Vision. The CV there stands for computer vision. So what is computer vision should be the first question all of us are asking now. Well, to give it to you in a very simple manner, computer vision is basically finding a very simple way to help your computer or any machine for that matter understand what it is seeing. Now, you might be a person who says, hey, I have the latest and the greatest computer. It is the fastest one. It's a gaming machine. It's super intelligent. I agree, but at the end of the day, even the most powerful supercomputer that we have in the world, at its most functional level, right, the more in depth you go, you will realize that your computer does not understand anything apart from zeros and ones, right? Of course, we're hunting towards artificial intelligence, but you have to realize that your computer works on zeros and ones. Now, when that is the case, of course, it will know how to open images, how to read images, write images. You have done all of this probably in your childhood. All of this is done, but at the end of the day, not just opening an image on Windows or Mac or anything, but making your computer understand what it is that it is seeing is a key part of computer vision. Right now, there are many popular applications of computer vision, and one thing that pops into my head right now is the one where people are doing mask detection, right? Now, you might have seen a couple of trending YouTube videos right from the start of 2020 till now, where multiple developers are actually, devising algorithms together and logic together, which will eventually look at basically it's a webcam feed, and as soon as it sees a person, it tries to detect if this person is wearing a mask or not. How amazing is this, right? And if you're a person who travels often, you might have seen automated check-ins done at the airport as well, right? So you just look into a scanner, it realizes that it is you, and eventually you're cleared and you have to go through all the security and all of that. So how does it know that it is you, who's standing in front of the camera there, right? Again, computer vision. So basically what we are trying to achieve with respect to computer vision is we are bridging the gap that exists between computer software, which at the end of the day works on zeros and ones, and the actual visualization that it has to see and understand, right? This is very important. Now, you are trying to make your computer more intelligent even with a basic library such as OpenCV. Maybe you give it a picture of a fruit, right? Or you send it a picture of a cat, you send it a picture of a dog, and then you say, hey, what is it that you're seeing? Now, this is very popular in machine learning. We call it as a classifier. Let's just say you give it a couple of images of the fruit orange and maybe a couple of images of apples, right? Now, as soon as you train the machine learning algorithm to make it understand what an apple looks like, to make it understand what a orange looks like, it can figure things out on its own. You can give it hundreds of different images of apples and oranges and it can still try to figure it out, right? Now, that is with the power of machine learning, which again OpenCV is 99% used alongside with. But you also have to understand you can use OpenCV in a standalone mode, wherein you can just work on basic image operations, you can work on resizing it, you can work on adding text, you can still work on face detection without having to use any other complex dependencies, right? So getting your computer to not just look at a picture but to understand what it has is everything you guys should know about OpenCV. Now, face recognition, as I mentioned, is the most popular application that has come out of OpenCV. Now, the name itself, OpenCV, is basically telling us that it's an open source library. When usually a library is open source, ladies and gentlemen, there are thousands if not millions of developers who just add on to the tool, who just add on to the library to make it way better than what it is, right? Similarly, Python is an open source programming language as well. That's the reason you see millions and millions of developers, and you see these rapid progressions in the versions of not just OpenCV but also Python as well, right? Now, that is one thing about OpenCV. The next question you must be asking yourself right now is saying, okay, so it's OpenCV, it works based on computer vision, you know what computer vision is, But what are some of these programming languages that we can use with OpenCV, right? You might think that, hey, is Python the only programming language that will work with OpenCV? Now, I am sure that you guys might have watched other videos. I'm sure that you guys might have done a little bit of research on this. And 90% of the time, whenever someone talks about OpenCV, it has to be Python on the other side, right? Now, Python and OpenCV, ladies and gentlemen, they go hand in hand because of the fact that Python provides you a superbly easy syntax to work with, and OpenCV talks really well, and at the same moment it is also efficient when it works with Python. But to answer the question, no, it is not only Python that OpenCV can work with. It can work with programming languages like R programming language, and of course there are many other languages as well, right? So if you're on the data science and data analytics train, R programming language and Python is what you'll be primarily using. If you're doing face recognition, you want to do intelligent face recognition based on machine learning, AI and all of that, OpenCV should be your go-to library, right? Fantastic. Now to talk about on which platforms can you actually install OpenCV and work with, right? So what are some of these platforms? Does it work only on Windows? Does it work only on Linux? No, guys. There are a lot of features given to you in OpenCV, and most of these, if not all of these, actually work on all the platforms that we have today, be it Windows, be it Linux, and of course for all you people who use Apple devices, it's available on the Mac OS as well, right? So it's open source, it's free to use, it's very powerful, it talks to multiple programming language, and it is almost platform independent, because at the end of the day, these are the three major platforms that people use, right? So you should already have a concrete understanding of why OpenCV might be so popular. Now, if this was a very niche paid tool that was available to the market, you have to understand that not everyone would want to be willing to spend their money or maybe spend their time if it does not have a large scope. But OpenCV is not the case here, right? OpenCV, the second OpenCV came out, of course it was open source, and everyone realized the power and the potential of it. Of course, back then when OpenCV came out, of course we did not have a lot of computation power. We did not have very efficient ways of teaching our computers how to look at images. But now this is a piece of cake for the computers, right? Once they understand and once they know how to work with images, and there are libraries in Python, these are like the helpers that will basically help not just the computer but us as the programmers as well, right? Superb. Now with this, you must understand where OpenCV fits into the picture, right? If we are talking about face recognition or face detection, let's just say. So you have an image, your computer looks at the image and it has to figure out where there is a face in the image, right? So where is OpenCV used, and if not, how is it even used in these steps? Well, ladies and gentlemen, let us start out by understanding the 4 very simple steps about how OpenCV sits into the picture. The first step, whenever you go on to do any sort of, let's just say, face detection again, is the fact that you're going to be gathering some information. What is this information? If you are actually going to do face detection, you're going to require a picture of a person. You're going to require an understanding of what a face would look like, right? Now, there's multiple instances where maybe you fed the face of a person looking straight into the camera, your computer understands it. But as soon as the person turns to the side like that, there's a very good chance your computer doesn't even know it's a face that it has to look at, right? So all of these things, you have to make sure that your data is very well intact, not just high quantity but also high in quality, so that your computer can figure out what's going on. Once you have all the data in, the next thing is you have to bring it to a format and you have to do a little bit of pre-processing on it, right? Nowadays, what happens is all the pictures that we click on our mobile phones, on our DSLRs, on our GoPro cameras, whatever it is, these are images which are either in the definition of 4K or Full HD. These are really large images, right? Now, it so happens that you don't have to provide extremely high quality 4K, 8K images for your computer to understand. Absolutely not. Even an image such as 600 by 600 pixels is something your computer would understand, and in fact it is something it would prefer because it is super fast for processing. And once you actually process it on a tiny part, on a small image, replicating it on a big one shouldn't be that much of an effort, right? So this is where you would think about getting your process to speed up. To speed it up, you just have to go down on the image size and eventually still hold the same meaning, right? You cannot skew the image and expect your OpenCV library to help you understand what the image is or maybe figure it out on its own. So a little bit of pre-processing side is where OpenCV is also critically dependent upon. Now, once processing is done, the next thing that you will have to take a look at is model training. Now, model training is the part where you'll be using all the data that you have gathered and eventually sending the data to all your algorithms that are running and saying, hey, here's the input data. Here's where you'll find all the faces. Now, you're basically training it to understand what a face looks like. And as soon as it figures out a face, for example, facial features include nose, two eyes, eyebrows, a jawline, beard, mustache, and all of that, right? So all of these things, if you train your computer to say, hey, if you find these kind of patterns, just understand that looks like an ear, that looks like a nose, that looks like an eye. Once you do this for hundreds and hundreds of images, eventually it knows what it has to be done, right? It is a very simple part that OpenCV can fit in all of these roles, but usually it's a step-by-step procedure, right? Now, after model training, what usually happens is you have to check if your model is working as expected or not. Sometimes you would have asked it to recognize a face, but there's a very good chance it would have recognized someone else's shoulder. It might have picked up the neck area or something else, right? So something has gone wrong if that has happened. Now you can actually evaluate, assess, and trace the conditions upon which your OpenCV library is being used on to check where something has gone wrong. Once you figure out where which metric is feeding wrong data, or maybe you have a human error in you actually providing the data itself to the OpenCV library. In those cases, you can figure out where it is, evaluate the performance of the model. You can even tune it to make sure that it works faster, it works better, and it understands how it can go on to not just recognize faces, but understand computer vision to a good amount of depth. You can do all of this in a very simple manner using the OpenCV library. Of course, we are going to be taking a look at a good amount of practical sessions to make sure that you guys understand this, right? So I hope with this, we are clear about how OpenCV is used. So if OpenCV is used in that way and it fits in all of these different different methodologies and different steps that we just spoke about, what is it that you have to know about OpenCV and Python, which is very important? Well, one really important thing that you should know about is that when OpenCV was built and at the same time when Python came about, of course, Python is very much older than OpenCV, but as and when development happens, OpenCV was developed to multiple versions, Python was developed again to stacked multiple versions as well, right? Now, in that case, basically OpenCV was being developed to not just be used with Python, but to be effectively used keeping performance as the most important metric. Now, when you have performance as a criteria, it becomes the fact that you want OpenCV to work really well with all the existing data structures and the libraries that are present in Python, right? Now, if you have worked with Python, you will know that there are two very nice libraries to work with if you need an extended hand with respect to mathematical operations and statistical calculations. Now, these are the libraries called NumPy, which basically stands for numerical Python, and the Pandas library. Pandas library provides two beautiful data structures for us to use. It's the series data structure and it's the data frames, right? So when you go on to work with all of these libraries, or let's just say you're a person who already knows how to code in the Python programming language and you're jumping to the image processing side of things and you want to understand OpenCV. Well, if that is the case, if you already know NumPy and Pandas, you have to understand that OpenCV is built in fact to make sure that it works really, really well with these libraries, right? So having the understanding that you can use already existing libraries and bring in a new library which will again work fantastic with these will give you a lot of flexibility, because at the moment you'll not have to worry about any sort of complex syntax that OpenCV might bring, because that is solved with Python. The next thing is you really do not have to worry about performance tuning or getting started with performance tweaking right at the beginning. Again, why? Because OpenCV and Python gel really well together, and again you don't have to worry about that for a good amount of time. So eventually you'll only be worried about the logic. It is about how you will get from your problem statement to the actual solution, and this should be hugely advantageous to you as a developer, especially a person who's working in OpenCV, because you will have the time and the effort to actually spend time solving the problem rather than breaking your head about complex syntax. That is again another huge advantage which put OpenCV on the map, and I'm sure you guys will appreciate it as and when you start working on it as well. Right? Superb. Now that we know what OpenCV is, we know that you have used it, we know how you can go about understanding it, how it works, where it fits, and how well it works with Python. Once we know all of these things, it becomes key, ladies and gentlemen, that you understand how you can go on to install OpenCV by yourself, right? Now, installing OpenCV is really simple. It is really straightforward, yet at the moment of time, it can get a little complex. It can give you a couple of errors. It might not work as expected with any of the Python IDEs that you might have. Some of you guys might be using PyCharm. Some of you guys might be using something else, right? Now, there are a lot of IDEs for Python, and you can be using any one of them. This is not IDE dependent or IDE specific, but at the moment while you're configuring it, things can go wrong. So just to make sure that you guys are starting to install OpenCV at this moment of time, you have to make sure of one thing, ladies and gentlemen, that you have the latest version of Python and the latest version of pip, which is basically the Python package manager. You have to make sure you have these in hand, because again, as I told you, right, OpenCV is developed along the sides of Python. So when there is something new, or when there is a bug fix that is done in Python, or maybe a new feature is added, OpenCV will ensure that it will make the full use out of all of these, right? So it is always recommended that you guys have the latest versions of Python, latest versions of pip, and of course when you're installing it by running the command that you see on your screen, you will be installing the latest version of OpenCV, right? So pip install OpenCV-Python is a very simple command to check it out. But are there any more easy ways to go on to install Python? Well, running one command, if that was not as easy as you thought, well, if you are using something such as Google Collaboratory is nothing but a Jupyter notebook that is hosted on the Google Cloud platform. Now, if you are a person who's using that, you do not have to install OpenCV specifically or exclusively, because it comes installed with that. All you have to do is verify if you have your piece of code ready and eventually start using it, right? Now, take a look at your screen. Once you go on to install it, be it on Google Colab, be it anywhere else, you have to verify that it has installed correctly or not. So just run a very simple command, import the library, and eventually run the second line here that you see, print cv2 __ version __. This will ensure that at the end of the day, if you have your OpenCV ready and working, this will print out the version of it, right? Now, let us actually take a quick look at the installation procedure and eventually about how you guys can begin working on this. Now, I'll do a quick Google search on OpenCV and let's head to their page right there, right? Now, as soon as I go on to the OpenCV page, they've given you a lot of introduction about their page, becoming, they're giving you the GitHub documentation. They have a lot of forums in which you can go on to talk to a lot of people, ask questions in case if you have any doubts about it. You can report any bugs in case if you're a developer, their wiki, their services. So ladies and gentlemen, you will find a lot of different things about OpenCV. Right now, let's just search for installing OpenCV in Python, right? That is what we are after now. As soon as I go on to do that, you will see that no matter what website you go to, they'll just say, hey, it's basically pre-built to make sure that you can work on it, and all they say is again the same thing, right? Import CV2 and work with that. Now, I told you that with respect to Google Colab that it comes installed with it, so I don't have to install it manually, right? So this is what Google Colab looks like. It's a very simple Jupyter notebook. Now, if you have not installed OpenCV, you would run this first line that I just showed you, right? Pip install OpenCV-Python. Now, in my case, I don't have to run this at all because of the fact that with respect to Google Colab, I have OpenCV already installed and ready. So what's the step after installing it? It's verifying and checking it, right? So I'm going to import CV2, which is a library, and I'm going to eventually print the version that goes alongside that. Now, as soon as I hit play, you can see that the version version of OpenCV that is installed is 4.1.2. So if you have a similar output, as soon as you run the command and you have an output which gives you a version rather than giving you an error of any sort, it means that you are set up and you are ready to go on further and take a look at all the practical things we will discuss in this session as well, right? Superb. So once we are set up with OpenCV, as you saw, it is very straightforward. It's a simple click of a mouse button and running one or two commands. Once you're done with that, you should be very curious to find out how the entire process of computer vision itself works, right? We spoke about OpenCV. We spoke about where OpenCV fits. We spoke about how OpenCV works in multiple steps, right from bringing in your data all the way to using your data to perform some data visualization or driving some metrics based upon that. We discussed that, but what we should also take a look at is to make sure how your computer looks at an image, right? Vision, we're talking about vision. So how does it understand that? It is very simple, ladies and gentlemen. There are 6 important steps of getting computer vision to work. Let's take a look at each of these steps. Step number 1 says inputting the image to make it accessible to the computer. Of course, you will have to input the image as in, you might have seen a JPG image, you might have seen a PNG image, a GIF, which is basically a graphical image, right? Now, all these various types of images, you can find out the compatibility with respect to OpenVision. Of course, the most common files that we use is a JPG, and I'm sure it's a PNG as well, right? So when you're inputting your file to the computer, you're going to be having a file with this extension. You're going to send it and make sure your computer understands this. So how do you get to the point where it understands that? That's where the next step comes into the picture. Step number 1 is just giving the image to your computer. Step number 2 talks about extracting RGB values of each pixel. Let's break this sentence down, right? So let's just say there is an image on your screen right now. Of course, this is an image of a face detection example, right? So as soon as I see this, I understand it, but how do I get my computer to understand? Well, you have to realize that an image is composed of pixels, right? Now, when I say I can shoot in 4K definition or I can record in 4K definition, what I'm basically meaning is a definition. It's an aspect ratio, not just an aspect ratio, but the resolution that goes alongside with the aspect ratio, right? For example, you might have heard 1920x1020. Well, 19201080 is nothing but the resolution, the number of pixels that goes into making the standard, what we call as full HD or full high definition, right? So each of these points that you see here, there is one pixel that is basically lighting up to add purple color to this, to maybe add blue color to this, to maybe add yellow color here, right? So each of these colors, they're basically called as channels, and you have to understand that there are 3 primary colors, red, green and blue, and with just these 3 colors, it is possible to create any other color that we want, right? That is the reason we consider these as the standard. Now there are multiple other colors as well. When you think about cyan, when you think about yellow, when you think about black, with which you can also create multiple colors, but of course the most popular version, the most popular model that we have is the RGB model, right? Now once you go on to extract RGB values, as in, let's just say for example that this image is maybe a 300 by 300 size image, right? Now what is 300 multiplied with another 300? That is how many pixels that you have, and each of those pixels will have one red value, one green value and one blue value, which will eventually together work in hand. It will work together to give you a color, right? Now if it is blue, just one shade of blue can turn on, but look at this. So on your screen itself, you have 4 shades of blue, right? Now look at this. The tab on the left that I have is a different blue. The one on the upper side of the title is blue. This is also blue. We have a blue in the OpenCV logo as well. And of course, we have multiple variants of blue, purple, and all of that put on the screen here. So instead of you just saying, hey, since it's just blue, just turn it on and just leave it at blue. No, that will not work, because it is not just one color that we're talking about. We can create millions and millions of colors. So extracting the RGB values for each of these pixels in an entire image is step number 2. Once you do that, once you pick up each of these values and you tell your computer that these are the values of these colors, it will have an understanding of what is going on. Now, if you're trying to send a picture of, let's just say right now what you're seeing on the camera feed, right? If I click a picture of it from your perspective and send it to the computer, it will know that there is a background here and there's a face here, right? So the background will be lit up because it looks white, it is bright. So there are a lot of background values. In fact, that is what your computer is doing at the moment right now. As soon as you're watching this particular video, you are loading these multiple pixels and it is showing you all these outputs, right? So getting your computer to know not just to showcase this output but also understand what it is, that is what comes in the next couple of steps, right? So at this moment of time, we have inputted an image to the computer, it knows that it is seeing an image, and we are also giving it the RGB values that are present for each of the pixel. It already has these values, but to use it, we'll eventually have to do all the magic that comes after this, right? Now, the most important thing that I already told you about regarding resizing of images, right? You can have 19201080 images, you can have 4K images, you can have 8K images, but for all that matters, your computer really does not need an extremely high quality image. And it is also easy to say that, hey, can I give it a very, very low quality pixelated image and get it to still figure things out? Well, no, there is a fine balance between quality and of course quantity as well, right? So if you look at an image and if it looks slightly pixelated, maybe you can figure it out. Now, if I give you a very pixelated image and you cannot figure anything out, well, if you cannot understand and think of the state of your computer, right? So it becomes very important that while resizing these images, you're still keeping the resolution intact, you're still keeping the aspect ratio intact, and you're making sure you're not skewing or messing around with the image, right? So if you just stretch the image in one direction, what do you think is going to happen? It's called a skewing, right? Now, skewing is possible with respect to OpenCV. In fact, it can also recognize and understand what it can do about skewing as well. But again, that is out of the scope of this particular tutorial. But with respect to step number 3, it becomes important that you guys understand that you'll have to resize some of these images, not just for the purpose of efficiency, but to make sure it works faster and you can use the same learning for bigger images later on if required as well, right? That's step number 3. Coming to step number 4. Step number 4 talks about how you can go on to perform image recognition or be it image detection by making use of some algorithms which are very popular for this. Now, image recognition, as I told you, right, you're going to be using a lot of images to train your computer, and as soon as it understands what it is seeing, then you basically ask it for recognition, right? So first you do detection. Whenever you go on to learn OpenCV, that is what is suggested, right? You start out with the basic operations, you understand how it works, then try to get your computer to detect something on the screen. Once it detects, when it says, hey, there is a face in the image here, next get it to work on recognizing who is the person that is present on the face, right? Now, in fact, if you are a very active user on Facebook, you will see this is exactly how the concept was developed. Previously, Facebook really did not understand or gave you any features. You had to manually click on the tag option, go and click on the person's face and then do it. Then a couple of years ago, you would just hover your mouse around the face of the person and it would detect saying, hey, there is a face detected. Who is this? It would ask you a question saying, who's this, right? That is when it is detecting the face, but it is not recognizing the face. And I think it was 2-3 years ago, that's when Facebook completely implemented face recognition, wherein you don't even have to hover your mouse around it. You upload an image and it will automatically realize who it is that is present on the screen. So to detect who it is that it is seeing, it has to first of all detect that there is a person, it has to detect who it is seeing, which we call as recognition, right? So it's very common for beginners and for people who have never worked with OpenCV to dive right into the heart of the concept and to work on recognition. But if you do not understand detection and if you do not understand the basic operations that will govern everything going ahead, it becomes difficult, right? So with respect to step number 4, understanding detection, knowing how recognition works and feeding all of these to your algorithms, which will do the heavy lifting for you, is important. Now coming to step number 5. Step number 5 talks about adding artifacts that will help you with step number 4. Step number 4, let's just say I gave my computer an image. For example, this is the actual image that we are going to give to our computer, right? If you take a look at it, there is a rectangle that is drawn on the face. What is the purpose of this rectangle? The purpose of this rectangle is to tell us that there was something detected in that particular region. correct? Well, to do that, your computer must have the capability to not just recognize the image, but also be able to change the image. When I say change the image, it has to draw a rectangular box on this image, right? Now, to do that, that is what we call as artifacts. Whenever you're running any sort of face detection algorithms or face recognition, it usually puts a rectangle box or a square box around the face. Now, what it is basically doing is it is either editing the same image that you provided to it, or it is creating a copy of it and doing basically working on another image wherein it will use the exact same image, but now it knows the coordinates in x and y axis where the image is, where your face is. So it will basically go draw a rectangle around it, which will not just tell the computer where the face is, but it will also tell you in a very simple manner, right? Now, if I gave you an image and if I told you, hey, there is a face at the coordinate 400 by 400, 300 by 300, 200 by 200, something like that, if I tell you, you'll be very confused saying, okay, I don't want these, I want to see where it is, right? That's the reason why we draw an artifact as well. Once you are done with the artifact drawing, maybe you want to add some text. It is possible. Maybe you don't want to add a text. Maybe you just want to add rectangles, circles. You just want to add a frame to it, border to it. Anything such as these operations are possible. Step number 6 is very straightforward. If you've followed through from step number 1 to 5, step number 6 is just finding the best way to display the result. Now, displaying the result, you can just show it on your screen, you can save it to the same file, you can save it to another file. A lot of opportunities are there for any sort of flexibility that is required for you guys to actually set up and go on to use these, right? Fantastic. The next step that we're going to take a look at in the process of computer vision is to understand some functions that we have. Now, with respect to OpenCV, there's multiple helper functions which will basically ease your load about what you need to do. For example, let's take a look at the first function, the cv2.imread function. Imread basically stands nothing for image read, image write, image show, right? When you say image read, well, you're trying to use it as an input to just pass the image to your computer. If you're talking about im show, or where it says image show, well, what are you trying to do? You're trying to show the image on the screen or in the working environment. If you're working in PyCharm or if you're working Google Colab, the output will be shown on your screen right there. But this doesn't mean that the changes that were shown on your screen, maybe you added a rectangle, right? Maybe it added the rectangle in the wrong place. So you just want to see it and not write it to the actual file. That is when you'll be using the show function. The show function basically just puts out a sample output on the screen so that you can see and verify if it has done something correctly or not. Now, once IMShow is done, the next thing you'll be taking a look at is IMWrite. Well, once you're done with looking at the image, the face either detected correctly or it didn't detect correctly, the next thing you're going to do is actually write it. You want to save it, right? This part is done very, very easily by this function called as ImageWrite or IMWrite, guys. So these are the three really important functions that you have to know. But how does one go on to use these functions? Well, to answer that question, let us quickly take a look at the syntax of these functions and understand what they do. Firstly, we have the imread function, the image read function. So you are supposed to give an image to your computer here. Well, there are two parameters you have to take into account. One is the file path and the other one is the flag. File path basically tells you the location of where the file is so that your computer can go there and pick up these files. And flag basically specifies how you're supposed to read these images. Now, we spoke about RGB values back then. Now, RGB talks about colored images. But what if there's a case where you only have a grayscale image, right? Now, when I say grayscale image, we call it black and white usually. So there's only one color channel that has to be picked up there instead of three color channels. A color image will usually have three color channels. A grayscale image will only have one, which is nothing but black or white, correct? So a flag specifies if the image is actually a color image or if it's a grayscale image. And there is eventually one thing you have to understand is what does this function return when you execute it. So when you execute this particular function, it will give you an image that is nothing but loaded from the same specified location that you guys put in the file path, right? We are going to take a look at this practically, so make sure you guys are staying tuned. right? Now, once that is done, once IM read or image read is done, the next thing we need to take a look at is image show. With respect to image show, you're trying to get it displayed onto the output window, right? In that particular case, there are two important parameters that you have to take into account here. One is the window name and the other one is the image to be displayed. Window name basically talks about the name of the window which has to display the file in. Now, if I give it one image, I just call it face, and the output that I want from it after face detection is maybe like face detection.jpg. That is where I would use that name. So whenever you open that window, it will give you an output on the top having that particular title that you mention in the window name. And of course, the next parameter is the image that has to be displayed, right? So what is the return value that you get when you're using image show? Well, there's no value or there's no Boolean operation that you get, but eventually what you see on your screen is nothing but the actual image itself. So it returns an actual image, but no return value is required for that function. Once we're done with that, the next function we need to take a look at is the IMWrite function, right? IMWrite or image write is basically you taking a file from a file path and saving it for your requirement. As I told you, you've given an image of a face to your computer, face recognition is done. You want to save the output now. To save the output to another file is where this is required. So of course, you have to give it the actual name of the file, as in what do you want to call the file as. One very important thing you have to make sure when you're giving the file name to be saved is to add the extension to it. It's going to be either JPG, JPG, or it's going to be something like PNG, right? So you have to add the extension specifically because it'll when it goes on to save it, if you have not added an extension, your Windows Explorer might have no clue about which type of file it is seeing. So it doesn't know what application it has to use to showcase this file to you, right? So file extension is very important. But if you just use the IMWrite function, it will not give you an output on the screen. It will just tell you if it has stored the image or not. So basically the return is a Boolean operation, and it will say true if your image was saved successfully. But if something went wrong, your file name was incorrect, or you gave some incorrect parameter to it, or your syntax is incorrect, you will get an error, or it will say false, as in this image could not be saved, right? So it becomes very important for you guys to understand that the return types of these three functions differ a lot. With respect to IMShow, you actually got the actual image as the output. With respect to IMWrite, you didn't get the actual image as the output. Of course, the actual image was saved on your hard disk, but it gave you a true or a false on the screen to indicate saying if something was saved or if some operation was performed or not. Right? Fantastic. So after we check out these functions, guys, the next thing you should be wondering about is what are some of these operations that you guys can do when you're working with OpenCV, right? Well, here are some really important operations that we are going to be taking a look at. For example, how do you read an image? How do you input the image and ask it to print its dimension, right? Dimension basically talks about the resolution of the image. So we'll check it out practically, saying how you can go on to do this. The next thing is we're going to have to extract the RGB values of the pixels, right? So we're going to do that as well. We are going to understand how you guys can go on to resize the image in any dimension that you want. For example, if you want to keep it structured, you can. If you want to skew your image and you want to pull it up, pull it to the side and skew it however you want, you can do that. We're going to take a look at that as well. And of course, when you're working with any image, maybe you're doing face detection, as we're going to see later in this particular session, is if you want to perform face recognition, and if you want to show that your computer recognizes the face, you draw a rectangle there, right? So let's just pick up an image and let's try to put a box in multiple places in these images as well. And after that, maybe you want to add a text to the image itself, right? You want to add an image automatically, maybe that says, hey, this person is wearing a mask, or this person is not wearing a mask, something along the lines of that when used with complex algorithms. To showcase how you can add text for all of those complex applications, you'll have to start out by checking out these, right? Superb, guys. Let's get back to Google Colab right now and check out how you can do all of these things practically, right? So let me just quickly open these basic OpenCV operations box and we can go on to work on these, right? Now, ladies and gentlemen, what is the first thing that I told you about? The first thing I told you about is us actually having to read the image, right? Look at this. imRead is basically the function that we're using. Image.jpg. Remember that I'm giving it the full extension as well, right? This is the image I wanted to read from the current working environment. If you guys are using PyCharm or anything else, you might have to give the full path to the particular file, saying C drive users your name / desktop / image.jpg. Now I don't have to do all of that because Google Colab basically uploads it to the same working folder or the same working environment. Now let me actually go on to delete some of these images that I've worked on previously so that we can show it to you from scratch, right? I'm going to delete. Okay, so now that it does not have any image on its hand, as soon as I run this, it will give me an error basically saying, hey, you were saying take the image and use it, but where is the image that I have to use, right? So let me just actually click on the upload button. Let me just go to my desktop and we have the sample image of a couple of flowers and a book. So let me go on to upload this image first. You can see that it's uploading. It's spinning out here. As soon as the spinning completes and the logo vanishes, it has uploaded. The next time we go on to run this command, it will not only read and input the image, but also give us the height and the width of it, right? I told you that we're going to be printing the dimension of the image. Right now this is uploaded. Let me close this, and here you will realize what is the the update that we have with respect to x. But x and y are calculated using a function called as image.shape. Let me run this again. Now as soon as I run this again, the image was red even though it is not showing. You remember we spoke about the return type of imRead. The return type, it does not have a return type because all you're trying to do is it is inputting the image. But here you see an output because I explicitly said, hey, I want to also look at the size of the image. Now look at the pixels, look at the height and the width of this image, right? So let me quickly open up a calculator to show you guys how many pixels will be there in this particular image, right? Let me put the calculator to the right for a second here. Let me move it a little to the top. Give me 1 second, guys. Right? Yeah. Now it says 6720 number of pixels in the height and these many pixels in the width. Now, as soon as I hit run, these are the number of pixels that will eventually go into creating this particular image, right? There are 6,000 pixels like this. There are 4,000. There are 6,000 column-wise pixels, and there are 4,480 row-wise pixels. And when you bring each of them together in a combination, that is the number that you get, right? Understand that this has no return type, but we are in fact giving the image to the computer. Now, what is the image that we send to the computer? Let me open the image to show you the actual one, right? This is the image that we sent. It's nothing but a white background. There's one book and a couple of beautiful flowers on the book. Okay, superb. Now let me quickly go back to Colab here, and that was for step number 1. Basically, us trying to get the computer to read an image and print what its dimensions are. The next step talks about extracting RGB values that are present in the picture, right? Now, we saw the number of pixels there. To print RGB values for like millions and millions of values will be absolutely meaningless. So what is easily done is for us to print an RGB value of one particular part of an image, right? So I'll just pick saying, hey, at this pixel at this pixel of height and at this pixel of width, basically try to find me the RGB value there. So in our image, even though we see that it is 6720 by 4480, I want to find what pixel is present at the point 250, 250. So when you say RGB equal to image of this, all you're trying to say is, hey, at this particular point, this is a point in space, this is the x-axis coordinate, this is the y-axis coordinate, or again, this is the width and this is the height. So when you go on to do that, you're telling it, find me the pixel value that is present in that particular point and print the RGB values for me. Right? This is what is doing. But we have one more part of it where we are saying, hey, I don't want the red value, I don't want the green value, I just want the blue value for that particular part. If that is also required, yes, you can have it. Now, as soon as I run this, it will say as, hey, at 250, 250 in your image, your RGB values are this. But if you just want the blue value at 250, 250, it is going to be something like 221, right? Just the value of B. This is super important for you guys to understand out here, right? Now, once that is done, The next thing that we're going to have to take a look at is taking a really huge image and eventually resizing it to the size that we want, right? Now, the example image is actually vertical, but 19201080 talks about a horizontal image. So when I use the resize function on a vertical image, I basically wanted to show you guys this particular thing. So what happens when I use this resize function is, of course, the image gets brought down into that particular dimension, and after it does that, if I don't run this particular line, it will never show me what the output is like, right? So I have to ensure that it gives me the output too. So I'm using the IamWrite function here to eventually create another file for me, and the name of the file is newimage.jpg. Let me run this right now, and what it is doing, it is taking my input image of this particular dimension 6720 cross 4480, and it is creating another image of this particular dimension, and it gave me a true. Now, why do I have a true? I told you this about in the return type that we spoke about when we looked at this function. So when it is successful in writing to a file, it will give you a true or a false output, right? If it is true, it means that there was an image that was created, and well, as you can see, right, the new image just popped up, and our image is ready in the other dimension that we want as well. But what we are trying to hunt for is not just resizing the image. So maybe I want to put a box around any particular pixel that I want. Now, these are the values of my rectangle. cv2.rectangle is a function which will help me draw one rectangle at this point. It's basically a line. Eventually take a right, go to the left, and find 4 points where it can draw a rectangle and draw a rectangle around it. And I'm going to write to the same file newimage.jpg, right? Well, let me run this function to show you what happens. We have in fact overwritten the same image that we previously converted it to 19201080, right? Now let me click on this, and as soon as this download, you'll see that it has added a box in the particular pixel that I have asked it to add a box for. Let me click on this and open it, and as soon as I open it, you might be wondering where the box is, right? It's a very small box that we might have added, but if I zoom in on the image, you can see that this is the box that has been added. Now, if you have checked out those mask prediction studies, or if you have checked out any of the applications where people have where the computer is in live, it is looking at a video and it is recognizing that if someone has worn a mask or not, what we are trying to tell that is, hey, here is a box, try to look inside the box to see if a person has worn a mask or not. Now this of course is not that complicated. All we are trying to do is just create a box in one particular part of the file. Placing a box is very simple. The next basic operation that you guys have to take a look at is how you can put not just a box but putting a text. Again, we have a function for this. cv2.putText is eventually the function that we're going to use. Output it as an image. What is the text that I want to put it? Where is this particular text that I want to put it? The name of the font I'll be using, the coordinates of which where it has to start, and more, right? Now again, I'm using the same CVWrite2 function. Let me run this, and as soon as I run this, you will find out why we need to use all of these things, right? First of all, it's simple. To what image should you actually write it to is done. The next thing is what exactly that you have to write. The next thing is the coordinate that you're going to have to put where the text box starts, and later it's the font that you're going to use. Now it says true. It means that it has written the text to this particular file called new image. See, for the sake of simplicity, I'm using the same file name over and over again, and it doesn't mean that you have to do the same. You can just put anything. For example, let me just type new image with text. Right, so just for the sake of readability, if I hit true again, it's just going to put the thing here, and eventually it will give me one more image. It will create another image for me here, which will basically say new image with text. Right, now let me download this particular image here to show you what it is that we have taken a look at. Now basically new image and new image with text are same in our particular case because we saved it once for new image and once for new image with text. Now as soon as I open this, there should be a box, and there should also be my name in that particular box, right? Look at this. Of course it doesn't look aligned, of course it doesn't look like it has any meaning, but the point of the goal here, or the point here, is to make sure that you guys understand you can put a box of any size, any dimension that you want, any number of pixels wide. If you want a thicker box, you can do that. You want a thicker font, a bigger font, a different color, right? We're using the blue color to just put a box and showcase the name. If you want to use green, if you want to use orange, if you want to use any color that you want, all you're going to need is the RGB value for those colors that you want to use. Just put them into the text box, put them into the actual rectangle function, and you guys are good to go. Right? Superb. So we saw how we can add a text to the screen as well. The next thing, in fact, the last thing that we're going to take a look at before diving into the demos, the face detection fantastic demo that we're going to be taking a look at, is to make sure that we also use this particular function called IMShow or image show. Now, every time we read an image, we wrote an image, it was basically telling us either it did it or it didn't do it. We never saw any image on the working environment itself, right? But with the help of this particular function, we're going to be reading an image and we're going to be showing the image.cv2 underscore IMShow. Now, as soon as I run this piece of code, it'll tell me that this is an image of the width, there's a height of this, and when it's a depth equal to 3, it's basically telling us it has 3 colors, red, green, and blue. If it was a grayscale image, depth would be 1. So since it's a very large 4K image, right, we saw the original image dimension here. The original image is 6720 pixels by 4480 pixels. So it's going to take a second for Google Colab to run through it, to read the image and eventually render it out. There's a process called rendering which has to happen, wherein it just shows you each of these pixels. Of course, you don't see it keeping one pixel after the other because it happens in a couple of microseconds, but it does take time to use the library to understand the image and check if it's correct. If it is correct, it will eventually give you an output that you can look on the screen. Right now, this should take less than a minute, so let's just wait until we see the actual output. Now, the point for you guys, whenever I tell you that you have to reduce the dimensionality of an image, is exactly this. If it takes this long for one image to work, imagine that you're using hundreds if not thousands of images for training a machine learning model or something like that. If it takes 30 seconds to open one image, it's going to take 30,000 seconds to open 1,000 images, right? So that's the reason why we keep it simple. We break it down. Now, this is the actual size of the image, right? Look, it is a huge image. Now, let me completely zoom out. Look at the size of the text right now. I'm sure for the people who are on your mobile phones, you might not be able to see it, but look at the size of the image. The image is absolutely huge, right? Again, you can compress it to any small pixel value that you want, which is still understandable, which is still recognizable, and eventually get all of these to work, right? Okay guys, superb. So this is how we can go on to install it. This is how we can go on to perform basic operations. Let's get back to the deck because we're going to be taking a look at a very interesting concept next, which is basically talking about face detection. Now, as I told you, there is a difference between face detection, there is a difference between face recognition. So let's start out by understanding what face detection is. Whenever we talk about this concept face detection, right, it's something that we've heard of a lot. There's a good chance we've used it also, but it almost seems like it eludes us, right? So what is it about face detection that we should know? First of all, one thing that should make you super curious about face detection is when you're learning it as, hey, so how can computers really detect objects in images, right? I mean, we as human beings are trained from our birth to look at something and know what it is, right? For example, I have a mobile phone in my hand right now. Now I can take a look at this and I can say, hey, this object is a mobile phone, right? Now I can pick up many other things such as that and say, I know it is. I know what it is, right? But then when you take a look at computers, if you just pass an image to your computer and ask a question saying, hey, what is it in this image? It can be very simple. It can be just a simple looking apple, let's say, right? A ripe apple fruit. If you give the image, your computer will have no clue what it is unless it is trained, right? So unless you train a picture, for example, if I just show my face to my computer as an image and I say, hey, guess who this is, right? It'll have no clue that there is a human being in the picture itself, first of all. Now, this is the reason why a couple of years ago, in fact, a couple of decades ago, researchers even picked up this topic and say, hey, can we have machines understand images, right? So that is where the entire concept of face detection and face recognition came into the picture. So what is face detection? Well, face detection basically is a very simple process of, inputting an image to your computer and having your computer assess through the image, analyze through what it sees in the image and to just put a rectangle or anything, it has to put a mark around your face, telling us that, hey, we saw this image, the computer analyzed the image, and we also, to make sure that, the humans understand that the computers are working fine, it will put a small rectangle box around it, telling us that, hey, we detected a face in this particular image, here is the face, right? So we're going to check this out practically as well. So this is face detection. But one thing you really have to understand is that there is a huge confusion that goes on between what face detection is and what face recognition is. I'm going to clear that as we go ahead with this particular session, right? Now, as you can see on your screen, look at the second point. The second point, say, face detection algorithms like Viola-Jones algorithms is very popular. Now, see, with respect to face detection and face recognition, there have been so many applications around us already that just like any other domains, we have some of these shortcuts that we can use to make our lives very simple in case if we want to do any sort of face detection or face recognition, right? In that particular case, we have a fantastic algorithm, Viola-Jones algorithm. Again, it's a very complicated algorithm to explain to all of you all and to go on to show why we have to use that. But at the end of the day, we are going to keep it as simple as possible with respect to theory and with respect to the practicals as well, so that everyone who's tuning in can understand every bit of the thing we are discussing out here, right? Perfect. Now, if you've ever wondered about using this technology, right, can we have computers understand something on the image and can we use it for any other applications as well, right? Can you think of something where you put in an image to your computer and your image sort of gives you something else? The most important example that I can think of right now is one that I've used practically, right? So when you usually away from India or when you're traveling abroad, many countries will have their native signs, right? For example, if you're in Japan, all the boards are shown in Japanese. So if I click a picture of a board which is written in Japanese and I just upload it to Google Translate or Google Lens, it will immediately, right, convert whatever is written in Japanese, use the same font, put it in English and show it to me right then and there while I have the camera open. Right now, it is not face detection, but you're trying to detect something on the screen, analyze it, assess it, and even change it in real time to give you an output, right? So Google Lens and Google Translate are absolutely fantastic examples of how you can recognize something in an image and add value to it, right? Apart from just using your face detection or face recognition systems out there. Now, in fact, a fantastic way of face detection and recognition both applies when we have to open up our mobile phones to unlock the screens. Right now, most of the mobile phones that we have today usually will give you a feature where you can unlock the mobile phone just by presenting your face to it so that it knows who the owner is. Right now, in fact, my phone does that. I've been using this for years and years. Right, so you can probably see here. Right, give me 1 second. Let me just open up my phone. Oh yeah, now I cannot open up my phone there because it will just tell me, right? If you can take a look at this, what I have here, right? The tiny thing that just came up and went back, that's the camera which was trying to detect my face. It says, hey, no face is detected because my face was not open, right? You can see that the phone is still locked. But then, of course, all of you all have done this, I'm very sure. Now that I just looked at it, guess what? My phone is unlocked, right? See, the phone is unlocked. Now, that's the most simple thing. Here, guess what? Face detection is being used and face recognition is also being used, right? But then we'll get to the recognition part. We're still in the face detection part. What you really need to understand here is even before you go on to perform anything else with respect to any face related technology, right? Detection, be it recognition, or you're going to use your face to change something, the concept of deep fakes, if you guys have heard, right? So anything with respect to having a face and changing it, modifying it, doing something, always starts with face detection. You really have to detect a face in the image to do something about it, right? All the concepts of anything related to face technology depends on this, and this is a very important point that I wanted to bring to your attention so that this kind of a build-up that we are having for face detection, you're supposed to be very clear at all the steps, because face detection is exactly the demo that we're going to take a look at, and having a simple yet powerful demo will add so much value to your learning at this moment of time. right? Perfect. Now that we have taken a quick look at what face detection can be, let's take a look at what face recognition is, right? Now, you guys watching the video, can you quickly pause the video, head to the comment section, and just put down in the comments saying what you think is the difference between face recognition and face detection, right? Of course, I'm going to give you all the answers, but I just want to make sure that you guys are giving me your opinions as well, right? So this is mostly like a conversation. You guys watch the video. If you have any questions, any comments at any moment of time, you guys head to the comment section, you put your comments down, and I will be more than happy to reply to all of your comments in case if you have any sort of doubts, right? Perfect. Now, I hope that you guys took a second to pause this video and put down the difference between recognition and detection. In fact, the difference is very simple. Before we get to that, let's take a look at what face recognition itself is, right? In any sort of face related technology that I've mentioned, even though I said that face detection has to be the first step all the time, you really have to understand that it is the first step to what, right? 99% of the time, face detection is usually the first step to attain face recognition, right? Face recognition, again, is one of the most popular applications that we have in the entire world of, how we can go on to use computer vision in itself. We're going to discuss about all of these in the next couple of points, right? Face detection is basically how you detect how the computer understands what is present in the image and identifying a face that's present. But face recognition is very different. Face recognition involves not only just detecting a face on the image, but also recognizing who the person is, right? So you really have to think about it. It's two different things. One thing you really have to know about recognition, which is very different from detection, is that for face recognition, you are going to require deep learning because it is very complex to teach the computer of what my face, for example, looks like, so that when I give it another picture of me, or maybe I have hundreds of photos of me, right? So if I just start pushing it and asking the computer saying, who is this, who is this, who is this, once it gets trained and it understands all the features, right? Like, for example, what my eyes look like, my face shape, my nose, my ears. So that is how this technology even works to get started with. Everything is broken down into features, right? So you can have edges, vectors, vertices, where your entire face is actually mapped using mathematics. All the concepts of statistics and mathematics come into picture, and we're going to apply all of them where it's going to understand who the person is, right? That's the exciting part of face recognition. But then to get to that, things can get really, really complex, right? So to make sure to get you guys started towards face recognition, our goal is to make sure that you guys can first of all do the first step. What's the first step? Face detection, right? That's going to demo we're going to talk about. Now, you have to understand that face recognition is used in hundreds of applications around us, right? So if I say it's used in hundreds and thousands of applications, are everyone clicking pictures and just, uploading pictures to their computers all the time? Well, not really. You can do face recognition, you can achieve face recognition by doing multiple different things. The first thing that you really have to think about when we talk about face recognition is either two or three things, right? First of all, do we always have to use images which are already ready, as in images which have already been clicked, right? Not really. Of course, one way of how you can achieve face recognition is by using images which are already clicked and present in your gallery. The second thing is you can open up your camera right then and there, click a picture, upload it, right? So you're doing both things. So hence I just thought I'll just mention it in the first point. Look at the second point. It says live webcam feed. Now, live webcam feed is very interesting, and I am very, very sure you guys have seen this, right? So as and when you usually open up a webcam or you're performing some sort of, there was this very popular application which got super famous in the COVID-19 era that we're living, is a mask detector, right? If you've taken a look at a mask detector, it basically looks at an image, finds a person's face, and it reports it live, saying if this person is wearing a mask or not, all from webcam feeds. And that is just one application. Another application you can think about is, in fact, you know what, when we get to the application section, we're going to talk a lot about this. But yes, you can have a webcam. In fact, I'm recording this using a camera itself, right? Now, you can have a webcam, and in fact, I can send exactly this video to my computer if I have a face recognition system ready to ask it, saying, hey, who is this, right? So after training, there's a good chance it can pick up my face and give me a probability saying, hey, I think 85-90% probability this is Anirudh, right? Now, that is the absolute fun part of working with face recognition. And the third thing, of course, guys, it should really not come as a surprise to you, right? Recorded videos, of course. If you can give it images, if you can give it live images, if you're giving it a webcam feed, you're giving it a video, there's a good chance you can also give it a recorded video, right? So this really shouldn't surprise you. And these three are not the only ways of how it's done, right? A live feed is exactly what I used to unlock my mobile phone. And static image is exactly what Facebook uses when it recognizes you and it automatically tags your friends. But whenever we're trying to monitor traffic or whenever we're doing those mask related applications, that is when you're either using a live webcam feed via video or you're already using a recorded video from the past, right? So this is something you guys really need to know. But then, as I mentioned, right, you will have a question, or you had a question at the start of the session, I'm sure, saying, is face recognition any different from face detection? The answer is absolutely yes. Face recognition and face detection are two very different ball games, even though they seem very similar, right? Look on your left, I have an example that shows face detection, right? Now here, with respect to face detection, you can see all these lines that are plotted across the face of this person, right? This is how your computer understands that, hey, there is a face in the image and this is what a face looks like. And as soon as it does this, it realizes that, hey, I just found a face. So it just puts a mark around the face. In this, you can see that there is a rectangular border that is going on, right? So that is face detection. Now take a look at your right side. Right side, we're talking about face recognition. Why? It just doesn't say, hey, I detected a face. It says, hey, I detected a face and I also know who this person is. This person's name is Kathy. Right? How fantastic is that? On the right, you're recognizing the person in the image, which again is a very different thing to just seeing a face and saying, hey, there's a face there. Right? Understand this. This is the very simple difference. But then take a look at the recognition side of things. To get to this point where your phone says, hey, I recognize the person, you have to detect that there is a face and map it, match it, and find something from the result of your learning to bring it there and say that this person is Anirudh, this person is Kathy, or whoever it is, right? This is something where, the deep learning aspect comes into the picture. So I hope we are very clear at this moment of time of our understanding of, how one can go on to take a look at recognition and how one can go on to split and separate face detection from recognition. Detection is used for recognition as well, but that doesn't mean detection is recognition, right? Now, I understand detection, recognition, we're talking about it so many times, it can get a little confusing. That's the reason why we really have slowed down and you can see images on your screen so that you guys are not confused, right? Perfect. Now, we will get into a very fun discussion when we're talking about the applications of face recognition see, again, we can talk about the applications of face detection as well, but then everywhere we're talking about recognition also requires detection. That's the reason why I thought we can have this discussion to save some time and also talk about some fantastic applications, right? Perfect. The first application should come as no surprise to you. In fact, I just gave you a practical demonstration using my mobile phone, right? So you use it as a locking mechanism for your devices. Now, of course, you guys have used face recognition and, locking it with the face. It doesn't mean that if I lock it with my face, if my sibling or my friend opens it, it'll open. No. Why? Because my phone knows what my face looks like and it'll only open to mine. So the next question you might ask saying, okay, so what if you're sleeping and I just put the phone in front of your face and I still have it unlocked? No. So these modern face recognition and your phone lock systems will only work if you have your eyes open and you're looking at the camera, right? That is like a safety feature. Or else if everyone was sleeping or if you already have a ready picture of, someone sleeping, you can just show that to your camera and it would rather open. Right? That's the reason why it's awarded. Nowadays, usually Apple does this. They have a sonar, a radar kind of a technology into their Face ID where it just projects a laser onto your face and it maps your face in 3 dimensions, and that is how it understands that this is an actual person and not a photo, so that you cannot cheat it via photos as well, right? In fact, yes, see, I have my eyes closed right now. I don't know if you can see my phone. I'm sure you can, but the camera is still upstairs, right? It couldn't recognize who I am. But then if I go on to just quickly look at it and then open it, there you go. Within a couple of milliseconds, the phone was ready, right? Exactly the demo outcome. out here. I'm sure you can do this on your own as well, right? Anyway, coming to the second point, it says prevention of retail crime. Now, how are we preventing crime with face recognition, right? Think about it. All these supermarkets, all these stores where there's cash being transacted or where there's products, and you usually see in these movies where someone brings a weaponry into a retail chain and just takes away all the cash and runs away, right? But if you have a very potent CCTV system, which again records stuff in high clarity, what you can do is you can actually take a picture of what the person looks like and even their physique, and you can try to map it with other suspects or other people who might have been arrested for similar charges, and you can do a ton of different things rather than just being robbed. I mean, God forbid, let's hope no one gets robbed, but that's the thing, right? Instead of just having being in no place to actually say who the person is, why not use your computer and why not use the entire database that the police will have to actually recognize who the person is that just robbed you, even though they might have masks on and everything, right? This has happened. Cases have been solved in the past using this. I absolutely love face recognition, guys. And then third thing is finding missing people. Yes, this is another superb application, which again I was researching on for a couple of weeks, where I was trying to find, hey, how do you find a missing person, right? So usually if there's public CCTVs, governments can have access to all of these public CCTVs, wherein they'll be running an algorithm on top of the video it sees. So for in any instant, any camera across, let's just say United States, finds a person who is maybe a suspect in a murder, or let's say even a retail crime or whatever it is, it will detect that person's face, automatically call the cops and say this person was detected in this particular city at this time, maybe at this restaurant, and we have the video feed to prove it as well, right? Look at that. We are saving crime with face recognition. Fantastic, right? Look at the fourth point here, guys. It says identify people on social media platforms. This has to be the biggest boon, at least in my opinion, whenever I have gone on to use social media, at least back in the day. Now I really don't use it a lot, but when you think about it, Facebook was super popular. It is still around, of course, it's still popular. So whenever you uploaded pictures of your vacation, you and your friends, right? Maybe you and 3 of your friends went on a vacation, you clicked hundreds of pictures, now you upload everything on Facebook to show off to the world. But what's happened, right? It will not show in all of their timelines, right? All of your friends' timelines, because they're not tagged into it. And instead of you manually sitting and tagging, Facebook will automatically find who it is. It will detect the faces. It will put a rectangle around it. It will also recognize the person. It will automatically tag the person for you, and it will also put a copy of it on their timeline. It will do everything that I just said automatically without you really having to do anything. How absolutely fantastic is that, right? Now that is again a superb application which is being which has already been subtly integrated into our life, that we think that, meh, you know what, it's there, it's working, right? But then you really have to understand that it takes a lot of complex programming. It takes a lot of complex working to even get to that point where it feels like, hi, this is a simple application. No, detection part of it is very simple, as you'll see, but recognition is pretty difficult to obtain. But then again, nothing is super difficult, right? So let's also make sure that in the near future we'll have a session where we will be discussing about a demo regarding face recognition as well, right? Perfect. Now let's take a look at 4 more applications before we can quickly go on to discuss other things. Right. The fifth point in discussion that I want to talk to you about is easing travel load on airports. Right now, again, I am an avid traveler, so I keep traveling all around the world. And every time you're in an airport, looking at those long queues are absolutely disastrous, at least for me. So during this COVID time, I saw in a couple of places in India. Again, guys, make sure you're not traveling unless it's absolutely necessary, right? So I'll give you an example. So when this was in 2020 when India was starting to go into lockdown, right? So if traveling around a couple of airports, to make sure that there is less physical contact, a couple of airports have automatic check-ins, right? Now there's so much features there which are absolutely fantastic. You just go there, you show your face to a camera there. One, for security purposes, they will verify instantly to make sure that you're not someone who has ulterior motives inside the the airport. Two, it'll also make sure that you have checked in and you're inside the airport. There was a time when you had to manually go to a check-in counter, and they'll give you your this thing boarding pass. You have to check in your luggage. Now all of that you can do it automatically these days, and all you have to do is go show your face. And maybe if you're flying an airline, the airline will immediately get a message saying this person has checked into the airport, right? So you entirely removing a manual process and automating 3-4 steps with the convenience of the customer just having to look at a camera, smile for 10 seconds, and saving what, 35-40 minutes, right? That is an important thing that I personally have used a lot of times, and I find it super fun, and I really would want this technology to be again, the technology is complicated to implement, but since it's already done, it would be fantastic to see it everywhere around the world, right? So you guys can also enjoy it every time you guys fly. Okay, the next point talks about aiding for forensic investigations, right? Of course, whenever you have any sort of images, evidences, or any sort of these cases going on, there will always be times when there is that one piece of evidence that will solve the entire crime, right? And that is usually all those evidences usually have a picture of a face, maybe of a person, an alibi, or whatever it is. So that piece of the information can be obtained from, of course, the trillions of photos we have in today's world by, again, putting certain algorithms into play, teaching them what the face of a suspect looks like, a suspect as in the suspect in discussion, and ensuring that it just hunts every image to make sure it finds these persons, right? Now, one train of thought you really should have is, hey, will that not require a lot of computing power? Of course, we're talking about governments of countries out here, right? And all the governments, if I'm sure, or almost all of them have supercomputers to their access, right? So they really can use all of these things. The third thing, which again I find absolutely fantastic, is tracking school attendance, right? There was a time when we were kids where they used to call out our names in the register, where we had to get up and say, hey, we are present, and they used to look at us and verify it manually, right? Nowadays, you can really save a lot of these processes by having a camera in schools and colleges, right? Have the camera ensure that it can see all the students' faces, right? As soon as the class starts or something like that, it can actually detect all the faces and attach the attendance automatically if the student was present there or not, with zero confusion. There is no back and forth with the faculties. There is nothing. You just go there, sit. The computer recognizes that you're attending the class. Right, done. How cool is that? But then it might be a little difficult if you have to escape classes for fest duties and for all the cultural stuff, right? Just kidding. Okay, let's take a look at the last point quickly. The last point we're talking about is identity validation at ATMs. Right now, this is very important, right? Just go to the news. Just open up a new tab right now. Hit Google. Just type in ATM fraud, or just type in someone got mugged at ATMs, right? You'll see that there is tons of people who get mugged at ATMs, or people who have been threatened with weaponry to steal cash and do a lot of hate crime there. But when you're talking about identity validation, you can solve some of these problems, right? So if I have my debit card, this can be seen as a limitation, but I would see it as something that might work, right? So only I get to withdraw money using my debit cards and credit cards. How will the ATM machine know who it is? Well, of course, it will see my debit card as soon as I insert it. It's going to open up the camera. It's going to probably just take a quick look at my face and then detect it, match it with their algorithm in the back end, or it can even have a person there, right? That's how usually technology starts. There's a person who sits there to manually verify something, and later everything is automated, right? So of course, we can get to that point as well. Knowing that these ATMs are monitored 24/7, the ATM can just understand that, hey, this is Anirudh withdrawing his money, let's just allow, then proceed, and only then the cash is dispensed. Else it can give you any other reason as well, right? But then of course, if it's a medical emergency, there's a lot of headache. But that's again a technology where a space where you can explore a lot, and of course you can do all of that using nothing but face recognition. Now, to quickly give you a theoretical idea of how face recognition actually is implemented, using deep learning, let's discuss this theoretically. Let's understand it in a simple fashion. So maybe in a couple of days or in a couple of weeks from now, we can have a session where we're going to discuss how you all can perform face recognition practically, right? But then to get to that, you have to make sure you guys are clear with this particular demo that we're going to discuss in terms of detection. But then let's come back to face recognition. See, what usually happens when you try to attack the concept of face recognition and you want to do it on your own as a learner or as a person, as a researcher, whatever it is, right? This will exactly be the train of thought that I'm about to tell you right now. The first thing whenever I try to solve any problem is I try to find the data set, right? I need the data set because I need to understand what it is that the data is telling me, what I can use from the data. And a very important thing is how I can use the data to the best of my abilities to find all the top features, use the top features, try to see if we can have machine learning, deep learning, try to see if we can automate something there, or perform exploratory data analysis as well, right? So data set is the first thing for me. Now, when you're trying to think about face recognition on a worldwide scale, training a network that big is going to be super complex. It's going to take a ton of data and it's going to take a ton of computation power, correct? All of these are again accessible, right? When I say ton, I'm not talking about having 10 i9 or i7 computers glued together to work. You can do all of these things practically yourself to get started, but then I'm telling you the practicalities of teaching a network, right? Take a look at the second point. This is how we usually work with whenever we're thinking about face recognition. We use a pre-trained network. Many times, we have this data set trained by this person called Davis King, right? It's a data set of 3 million images. It has used a data set of 3 million images to learn continuously and to have a very high rate of efficiency, right? So you don't have to train another neural network. You're using a neural network that was trained by someone else, right? And there is a very fancy term, if this is machine learning, it's actually called as transfer learning, where you teach something on one data set and you just use the same learning or the knowledge to see if you can test on another data set, right? It's called transfer learning. But as we're talking about deep learning, you have to understand this. We already have a pre-trained network. That is how, all you guys, beginners and intermediate users, whenever you go on to learn these, this is what makes your life simple and give you fantastic looking results when you perform face recognition, right? But then you might have a question saying, okay, even if I showcase images to my neural network, how will it understand images? Right? It will understand images as numbers, as mathematics, as vectors, right? The output of the neural network is basically a vector that consists of usually somewhere around 128 numbers. And each of these numbers will represent like an important feature of the face. Maybe it'll talk about how blunt your nose is, how long your nose is, your eye color, how far away are your eyes from your forehead, how big is your forehead, do you have a beard, do you have a mustache? So there's a ton of features here that gets detected, right? 128 different features, in fact, where it will give you an output saying, hey, this is what is mapped to this person, and these are how much percentages of vectors that were mapped. So there is 100% or 99%, 98, 50%, 60% probability that this is the person. That is how it works in terms of data set, right? So what do you usually do once you have a data set? Once you have a data set, the first step is to perform face detection, of course, right? This should not come as any doubt to you. As I've already told you, with the detection and recognition, no matter where you're going, you really have to detect the face first. So, in an image, there can be a lot of different things. There can be a background, there can be a mountain, there can be someone who's facing backwards, there's another one looking at the camera, right? The photos, endless possibilities. So the first thing that your computer really has to do is to find the exact location of where your face is, right? It sees an image, and look at this. In fact, the image on your screen right now, I was talking a lot about it, right? It's giving you the entire head form. It is telling where the eyes are, where the cheeks are, where the nose is, where the lips are, right? So it knows, it understands that, hey, this is the person's face. We're going to use this, and we're going to maybe take a screenshot of just that face to map it to other faces that you will have in your database, right? Step number one, that. When you're talking about step number two talks about feature extraction. As I just mentioned, right, we really need a mathematical numbers from an image or a face that we've seen so that it can be used later to convert it into a number, an image to a number, where this technique, when we go on to do this, right, embedding is basically what it's called as. It's actually also known as deep metric learning. Deep metric learning basically uses a function, in this particular case, a function of an image, where we're trying to find all of these features and we're you're trying to extract these features. And in fact, let me go back to step number 1. You can see that, right? For example, the eyes will get one feature, the left eye and the right eye. The cheeks will get another number. The nose will get a number. The lips will get a number. So you can use all of these vectors to actually map what a face looks like, the structure of a face, and the underlying meaning of what it's seeing as well, right? Now, that is step number 2. So I hope you're clear with step number 1, which was detecting your face. Step number 2 was, after you detect the face, you really have to make sure you convert it into vectors so that your computer or your neural network can understand something. Now, once that was done, the next step is what? You have everything you need to input into a neural network right now. So we start training a network, right? Look at the image on your screen right now. You will see 2 images of Arnold Schwarzenegger and 2 images of the President of United States, the ex-President of United States, George Bush, right? So a neural network will output faces which might look very similar to each other. If that is the case, what is the solution then, right? Now, maybe I just asked the question saying, hey, find me faces of Arnold, and it just brought out faces of George Bush as well. What do I do in this situation? If your face is very similar, you basically perform another iteration of analysis where you dive more into the depth of the network, right? So you can have multiple hidden layers in the neural network, which will eventually get to a point where it can accurately tell that, hey, this is George Bush, this is Arnold Schwarzenegger, right? I'm just glad I picked up Arnold's name because his second name is super complex to go on to tell, Schwarzenegger. Right? Cool. After step number 3, we'll come to step number 4, guys. Step number 4 talks about how you can use feature map to go on to actually understand something of what's happening around the face of a person, right? So after you train a network, it'll basically group all. It's called as classification, it's called as categorization, it's called as grouping. Everything means the same. So what your neural network does after training is that it will go on to map all these features and say, hey, look at this. These 2 pictures of Arnold looks very similar. So can this be one person, yes or no? In that case, the neural network could have given an answer saying, yes, that's the reason why you see both the pictures of Arnold in one section, right? And in another section, similarly, it would have taken a look at images of 2 images of President Bush, and it would have taken a look at it. It would have understood saying, hey, these people look like the same person. Can we combine it, right? So this is step number 4. Just mapping all your features, training even harder to ensure that you can understand something. And once you start looking deeper and deeper into the face of a person, right? Now, when I'm saying a face, think about it from the neural network perspective. So when you're having a deep dive into it, there is only a certain limit where it'll work really fine, right? If I have an image, what if I continuously keep zooming into it without any stopping, right? Eventually I'll get to pixels. Each pixel makes up an image. Here also, if you think that if you just train your neural network a lot, it'll work better. Sometimes, especially for face recognition applications, your neural network can overfit as in will start picking up noise and useless things, which will eventually affect your model efficiency a lot, right? So it doesn't mean doing it more means you're doing it better. No, you have to be very careful of overfitting for face recognition, because people don't realize why their models are going wrong, and by the time they realize that, it'll be too late for their application, or that it'll be a very simple analysis of at the end of it saying, oh, I should have just taken a look at overfitting, right? So that's the reason why I'm giving you this kind of a pro tip that you guys can use when you are learning face recognition down the line, right? Perfect. This brings us to step number 5. Step number 5, we're here after your neural network has learned, and of course we're going to be using all the images, and we're going to be using we're going to be basically computing the face embedding for all the images that are there using the same network. And if you do not have embeddings, what will usually happen is, I'll give you an example here, right? So let's just say we have a network which understands what President Bush looks like. So it has some sort of a reference, it has an embedding to get started with. But then I have a picture of President Putin as well, but President Putin, the embedding of this particular person was not saved. So what my neural network will do at this moment of time is it will not know who this person is. It knows that there is a person. It knows that there is a face. It knows that it probably looks similar to all these other people as well, right? I mean, come on. All these are human faces. There has to be some percent of similarity. But can it confidently say that this is this person? No. In this case, it will not, because if your face embedding is not not at all computed, it will not even know what it has to find or hunt in the face of this particular example to know what the person looks like, right? It's me telling you, hey, perform face recognition, but have a blind on your eye, right? Maybe wrap a cloth on your face and do it. It's not possible if I cannot see, right? Similarly, your deep learning network cannot learn unless it understands what it is, right? The same analogy of having something on your face covered to, you not seeing it practically. So perfect, guys. These are the 5 most important steps that you really have to keep in mind when you guys go on to, learn about how you'll be implementing deep learning practically. Now, along these 5 steps that we discussed, I not only told you what these steps mean or the order of how these steps work, but I also ensured to give you a couple of tips along the line in case if you guys are, training a model on your own, right? So I hope for all the people who are practically coding your own face recognition model here, that you can use some of the tips mentioned in all these steps to actually, have another footing or to have another approach to see if you can do something better as well, right? So that you can use. Now is the most fantastic part of our particular session is we're going to actually dive right into Python, and we're going to take a look at this particular demo that I have planned for you guys, where we're going to be performing face detection with OpenCV, right? But then, before we get to that, what is the most important thing that I told you all, right? The first most important thing that all of you all should really be concerned with is the data at hand, right? Now, let me quickly go on to my desktop. I'll open face detection files. I'll actually open up 2 files that I want to use to perform face detection, right? Again, both of these are my faces itself, but then both are very different. So I want to see if my this thing program can actually go on to solve and find and detect a face here, right? Let me open both the images, in fact, for you guys. Right now, these are my pictures itself. These are pictures of me, where one, you can see that I have a straight pose, and this sort of looks like me in short hair. I mean, of course, it's me in short hair. And then I wanted to see if this particular model can also find a face if it is sideways, right? Now, looking at a face head on, you can probably tell what a face looks like, but maybe my computer might not understand what a face looks like, especially if it's at the side, and if it's especially near an ocean and I have a specs on, I have a huge beard on, and I have a ton of hair, right? So everything in the image that you see on your right is meant to confuse that particular, confuse the computer itself, confuse its learning to see if it can be confused or not. But of course, on the left hand side, it's just my face, right? Both have my faces, but let's just see how we can go on to use these 2 faces to see if we can have some sort of result that we can go on to use, right? Perfect. Now, what I'll do is I'm going to quickly open up Google Chrome here, and I'm going to open up Google Colab, right? Now, Google Colab is basically it's a Jupyter notebook that's hosted on the Google Cloud platform. To get to Google Colab, all you have to do is you have to go to collab.research.google.com. Let me show that again here, right? collab.research.google.com. Or you just go to Google and type Colab, C-O-L-A-B, and that will be the first result that these guys will show you, because it's their own search engine from Google and it's their own product as well, right? Okay, now what I'm going to do is I'm going to sign into my email ID. Alright guys, so I just logged into my particular account, my Google account. Basically, if you have a Gmail account or any other Google account, you can actually sign in for free. Google Colab is a free tool to use. So the most simple thing that you guys can do is just start entering your pieces of code and start running it. That's it. You don't have to install Python, you don't have to configure Python, you don't have to break your head about why something is not working, how do you program the path, how do you work with the environmental variable, how do you do this, how do you do that. Absolutely no confusion, right? Just start typing your code, hit enter, and if your code is syntactically correct with respect to Python, it will work for free, right? Now, this is not using the computing power of my laptop right now. It's going to be using the computing power of all the servers it has, right? Huge rugged servers Google has for their Google Cloud Computing Platform, right? GCP. So this is basically a Jupyter notebook hosted on the Google Cloud Platform itself, right? Now, anyway, guys, coming to our demo, we're going to be doing face detection with Python, and we're going to be using the OpenCV library here. Now, understand what we're doing. We're trying to detect a face, right? So to go on to do that, basically, if you are thinking about how many lines of code are required, 100 lines of code is required, as I just mentioned at the start of the session, I'm going to be doing this on how many lines? 1, 2, 3, 4, 5, 6, 7, 8 lines. In fact, you can actually do it in 6 lines of code, right? Think about it. 6 lines of code and you're doing face detection. How simple can Python get? How simple can OpenCV get? And how you can just understand that if you have a face recognition project, right? 8 lines of code and you're done with face detection. So rest of the time you can actually think about how you can work on building the neural network and all of that for your recognition applications, right? Now what I'll do, ladies and gentlemen, is I'll zoom in a little so that all of you all, right? I know a lot of you, watch these videos on your mobile phone. So I just want to make sure that you all can see the code. And in fact, you can do it alongside me as well, right, guys? Let's get started. The first thing is I have to connect to the runtime here. I just connected. Let me go on to the runtime and see what type of runtime we have. It has to be a GPU based hardware accelerator because we're going to be using images a lot, right? GPU as in graphical processing unit. It's also called as a graphic card. Now it's not using my graphic card in the laptop. It just assigned me a virtual graphic card which is present in a server sitting anywhere across the globe in any of Google's data centers, right? So I'm using their hardware. I'm using everything from their side for computation purposes. And all I'm doing from my side is entering the Python code, hitting enter. That is it, right? Cool. Now, what is step number 1, ladies and gentlemen, when we're working with solving any problem? Step number 1 is to make sure you guys will always import every single library that you are going to require, right? So let me just click this button, and as soon as I hit that play and as soon as it stops rotating, you can see that I've imported the OpenCV library. If you had to manually do this, you have to download it, you have to pip install it or install it via Anaconda, you have to configure it. Sometimes it works, sometimes it doesn't work, right? I am sure you've been in that situation. But this time, all I did is hit that button and it's ready. Now, I told you about how most of the time we'll be using a pre-trained classifier from OpenCV to go on to detect faces for us, right? Or we'll have to just go through the entire step of having millions of images and training a network based on that. Look at this. One line of code, basically all we're trying to do is open an XML file which consists of it. It's called as the cascade. So when I go on to talk about how we'll have to go on to use this particular cascade, the first thing we'll have to do, ladies and gentlemen, is to upload the file, right? Or it's going to give us an error. So what I'm going to do, I'm going to go to my desktop and I have the files related for this, and I have this particular XML file called as face detector. Right now I'm going to open it and I'm going to upload it to the Google Cloud Platform. Now it knows where the particular trained file is, right? So as you can see, it's rotating here on the left, yellow color, and as soon as it completes rotating, it's basically trying to upload it and have it ready for us to use. And can you see this file here, face underscore detector XML? Now our file is ready. So what do I do is, as soon as I go on to run this, now there is this pre-trained network, all the data from our trained network which is already pre-trained and ready. So we have loaded the cascade. Now the next thing we need to go on to do is give it an input image, right? It needs an image of a face to see if it can detect anything. All I'm trying to do is use this method called as IamRead, and I'm just giving it the name of the file. Now the name of the file that I wanted to understand is test1.jpg. Now what I'm going to do, I'm going to upload it. Right now, guys, just to save time, I'm going to upload both test1 and test2. Okay, so as you can see, I'm uploading both the files, or else I just have to do it again. So now you can see that test1 is uploaded, test2 is uploaded. In fact, let me click on test1. Let me double click on it. As soon as I double click on it, on the right side, you can see what this image is, right? This is me. This is my face. Fantastic. So I have the correct image. So let me just close all of these things. So guys, the next step after I've actually uploaded an image, as you just saw, is to make sure that we can perform face detection, right? Now, face detection is a fantastic thing, especially with OpenCV. Is you can see this function called as detect multiscale, right? So this one function, this literally one function is going to be used by us to do the entire recognition aspect of things, to find where the face is, right? This is what is used. Now, as soon as I go on to click on this, now it has actually found out where my face is on the image. Now, how do I know if it understands this? How do I evaluate if it has detected my face correctly or not? Right? That is when I'm going to have to actually draw a little rectangle on my face so that I understand, hey, my computer knows where my image is or where my face in the image is, right? Now, as soon as I go on to click on this, all we are trying to do is we're trying to create a rectangle on our own image. So basically, we're trying to copy an image, have the image ready, in that find the X and Y coordinates, right? It's a two-dimensional image. It has X-axis and Y-axis. Then I'm just going to try to add these values W and H to basically go on to just find where my face is, center it on my face, and put a small rectangle there. Right now, as soon as I click on this, the rectangle is drawn on my face. Now, what's the next thing that I have to do? So after it has basically detected my face, right, the next thing that we're going to have to take a look at is seeing the result. So what I'm going to try to do is again one line of code. It says the photo is successfully exported. But where is the photo? Let me click on this, and it would have created one more file for us. It's called as face underscore detected.png, right? You can see that this is the output file. So this right now should be the output file, right? Let me right click on it. Let me hit download. And as soon as I click on download and I open it, you will be surprised to see that our face detection worked with 8 lines of code, right? Look at this. It found out in this image where my face is. It zeroed in on my face and it has put a blue rectangle on my face. Now, this is a very straightforward image where I'm looking into the camera where it looks like a guy. Now what I'm going to do is I'm going to want to confuse this particular model here. I'm going to change it to test2.jpg. Do you remember test2.jpg, ladies and gentlemen, where we actually go on to, have a picture of my face with really long hair and it's a sideways pose, right? So this is again me with long hair. Now I'm going to see if it detects my face here or not, if it knows what the face looks like sideways. Of course, it's been trained with multiple different millions and millions of images, so I'm sure it'll do it. So what I'm going to do is I'm going to start executing all these pieces of code again. I just changed test1 to test2. I'm going to run this piece of code, and as soon as I run this, it has detected my face. It has already seen it in the image, or it might not have, or it might have detected it wrong. We're not considering all those exceptional cases here. What is the next thing that we have to do? Draw a rectangle on the face. Once we draw a rectangle on the face, I'm going to see if it's correct or not. I'm going to export it. Now again, it might export it with the same name, or of course I can change the name here as well. Let me download it again, and this time of course it's going to be the latest one. It's going to be test2. Right now, as soon as I open this, it might have detected. Yes, you can look at that, right? Even with the side post, even with shades on, a lot of beard, a lot of mustache, ton of hair, and a very confusing angle on the picture, this algorithm understood. This pre-trained network was intelligent enough to say, hey, here's your image. And what? We're doing all of these, ladies and gentlemen, with 8 lines of code, and I'm very confident that I can convert all the 8 lines of code, maybe bring it down to 5 or 6, right? Now, this is the entire magic of Python. This is the entire magic of how one would go on to use Python with respect to OpenCV and with respect to face detection, right? Now you can definitely write a lot of lines of code going ahead from here. Once your model has already detected a face, you can use the detection, make your model take a screenshot of it, send that into a neural network, convert it into vector embeddings. Once it understands who the person is, you can perform classification, you can perform, you can give a probability of an output saying, hey, right? So let me actually show you this. Now, let me go to downloads here. Let me go to downloads. Let me open up the first image that it gave me, right? This one. Now, as soon as I look at this, it can take a screenshot of my particular face. It can detect all the features of it, and it can use this, in fact, to learn for maybe other faces that I might give of my own, right? Now, if I just use one picture to train my model and say, hey, can you please tell me who the guy in the side pose is? There's a good chance it cannot do that. If I've just trained it on one image, but if I've trained it on hundreds of images, it can tell me that, hey, a face has been detected, right? Now, if this was a face recognition system, it would say face detected, Anirudh Rao, right? It's not saying that because we've just done face detection here, but then this is the first step to get to recognition, right? Cool. So this was the simple demo that I wanted to show all of you all. And as I told you, it's very simple, right? It's a couple of lines of code, and you guys can do it alongside me as well. The Cascade file is again available on the internet. What you can try to do is you can take a look at any images of your own, right? I'm sure you will have pictures of yourself. Upload it, try to see if it can find your face or not. Head to the comment section and let me know about the result. Alright guys, so with this, I hope we are completely clear about how you guys can get started with OpenCV. We took a look at what it is, where it is used, why is it popular, how many programming languages can you use it with, what is the step-by-step procedure in which OpenCV fits into an existing structure, right? Apart from this, we also made sure to take a look at the process of OpenCV, as in each step-by-step, what happens when you have an image in your phone that you want your computer to understand, all the way to working working on operations and eventually transforming your image as how you desire, right? So we took a look at all of that. We installed OpenCV, we verified it's correct, and we made sure to take a look at understanding what face recognition is, what face detection is, and took a look at a superb demo where we discuss how you can go on to perform face detection. Right now in that particular demo, you can use your own faces. You can in fact input an image which has absolutely no face to see if you can trick your OpenCV library into finding a face where there is none, right? So there's a lot of room for you guys to not just do all the steps that I just did, but also make sure that you're providing your own images. Provide slightly confusing images, right? Maybe a photo of the side, maybe a photo right clicked from the back, clicked from the front, right? Try to see if you can find out where the limitation of OpenCV exists, because of course it's a very powerful library. But I hope again that everything we have covered in this particular tutorial is clear to all of you all. On that note, thank you so much for watching. My name is Anirudh Rao, and I'll see you on the next one.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.